Welcome to the lecture number 38, dear students. Last time we finished question number 1 of exercise 1.2. Now I am going to do question 2 of 1.2. Figure is given over here, and in this figure they have given the dimensions of PMS 15. Now you will find this PMS 15. Next to that PQ as 25. If PQ is total is given as 25. Try to understand this. This is 25. Next to that PR is 20. Total PR is given as 20. Then NR is given as 8. NR is given as 8. Fine. Question asked is, state NN is parallel to QR or not? Now you all know by converse of BPT, if ratio Pn upon Nr is equal to ratio Pm upon Nq, then by converse of BPT we can say that Nn is parallel to Qr. But for that I have to find out Pn first as well as I have to find out Nq first, because we don't know Pn as well as Nq. Pn and Nq are not known, so I am going to find out it. So you will find that P dash N dash R. These are collinear forms, isn't it? Then you will find this PR is given as 20, so Pn is equal to PR minus Nr. PR minus Nr. That will give us PR is 20 minus Nr is 8. That will give us 12. So you obtain here Pn we got it as 12. So I will write here 12. Fine. In the same way you will find I have to find out Nq, and PQ is given as 25. So I will write here Nq is equal to, try to understand, Nq is equal to PQ minus Pn. PQ minus Pn. But PQ is 25 minus 50, that is equal to 10. So this is how now these unknown values of Nq, I got it as 10 as well as this as 50. Now I can verify very easily converse of BPT. So let's verify. Let us verify. Converse of BPT. Converse of BPT. Now you will find Pn upon Nr. Converse of BPT is Pn upon Nr is equal to Pm upon Nq. So far I don't know. So I place a question mark. I don't know whether they are equal or not. So 12 upon 8. 12 upon 8. That is equal to 15 upon 10. 15 upon 10. 5 3s are 5 2s are 4 3s are 4 2s are. Therefore, Pn upon Nr is equal to Pm upon Nq. That is equal to 3 upon 2. Now we can surely say, or we can conclude, yes, Nn is parallel to Qr. Therefore, by converse of BPT, Nn is parallel to Qr. Nn is parallel to Qr. Very simple, because only the question is to find out unknown things that Pn as well as Nq. Since they are collinear points, you can very easily find out the values. Let's do here question number 3 now. Because in this exercise, all questions are based on only two things: BPT or angle bisector. We have to verify that only. Not so difficult one. Question number 3. Question number 3 is given here. In this case, you will find triangle is there. In this triangle, this is given. I don't know whether bisector it is or not, or we have to verify. Let's see in question what is given. So you will find that NQ is 2.5, NQ is 2.5, while that of QP we don't know. This is 7, this is 5, okay. Identical marks are given here, and fine. Find QP, right? You ask us to find out QP. Find QP. Okay, dear students. Now you will find these are the dimensions given. Now in these dimensions you will find, in this case it is very important that NQ is given as an angle bisector of M and P. It is given. So simply we have to apply angle bisector theorem. So we can say answer, since NQ bisects angle MNP by angle bisector theorem. By angle bisector theorem, now see which angle is bisected? N. N is a union of which two sides? MN and NP. So ratio of the sides of the angle MN upon NP, that is equal to MN upon NP is equal to corresponding parts. Corresponding part of MN is MQ. It should come in front of MN. Please take care. NP, corresponding part of NP is PQ. Let's substitute the value. MN is 5, while that of NP is 7. That is equal to NQ is 2.5 upon PQ. I substitute the value of MN is 5, NP is 7, NQ is 2.5, PQ. Now I am going to find out PQ. I will transfer PQ to the left side. So PQ is equal to 2.5 into 7 upon 5 into 7 upon 5. Now you will get PQ is equal to 2.5. I can write it as 25 upon 10 multiplied by 7 upon 5. Effect of this decimal, after decimal 1 digit. So while writing the plain number, I write 25 upon 10. So 5 5 is 25. 5 2 is 10. So PQ is equal to 7 upon 2. So PQ is equal to 3.5 units. So this is how you will find. Very easy sum, because it is already given as angle bisector. So we apply the theorem that MN upon N is equal to corresponding side MQ upon PQ. That is important. Substituting the value. This is important. 25 upon 10, and then by calculations you can do by different ways. That's understood, or that is acceptable also. So finally I got it as 3.5. Question number 4. As I stated earlier, these all problems are based on angle bisector or BPT, because so far we have studied these two theorems. Now question number next to that, exercise is 1.2 only. Question number 4. Figure is given, there is triangle ABC is given over here. Triangle ABC is here. This is triangle ABC students. In this triangle they have given us PQ. This angle is given as 60 degree as well as this is also given as 60 degree. Then to prove that, okay, then to prove that, AP upon PD is equal to AQ upon QC. Now you will notice very important thing. What things you will notice? PQ is intersecting AB as well as AC in two distinct points, P and Q. PQ is intersecting AB and AC in points P and Q. And if we prove PQ is parallel to BC, naturally we will get AP upon PB is equal to AQ upon QC by basic proportionality theorem. So what is our aim now? Our first step is to prove that PQ is parallel to BC. And it is very easy because you will notice one thing, that PQ, angle APQ is 60 and angle ABC is 60. What types of angles these are? These are corresponding angles. And if corresponding angles are congruent, naturally you will find lines are parallel. So we are mentioning a triangle ABC. In triangle ABC, angle APQ is equal to angle ABC, that is equal to 60 given. Since angle APQ and angle ABC are corresponding angles, correct? These are corresponding angles. Therefore, by corresponding angle test, by corresponding angle test, PQ is parallel to BC. PQ is parallel to BC. Therefore, in triangle ABC, by BPT, very simple. At once we prove PQ is parallel to BC, very simple. AP upon PD is equal to AQ upon QC. Just revise this now. We have to prove AP upon PD is equal to AQ upon QC. Very simple. You will find angle P 60 degree, angle B is also 60 degree. Since these are corresponding angles with respect to PQ and BC, you will get if corresponding angles are congruent, lines are parallel. Therefore, PQ is parallel to BC. But if at once we will get PQ parallel to BC, you can apply basic proportionality theorem that AP upon PD is equal to AQ upon QC. That is what I have written out there. So this is how you will find we finished question number 4. Okay, now let's do question number 5. In question number 5, it's a trapezium. Please try to understand, it's a trapezium. And very interesting to know that while writing the proof, you have to be a little bit careful because we are used to only of now basic proportionality theorem as well as angle bisector, and every now and then it is fixed in our mind that BPT as well as angle bisector theorem. But this is little bit interesting to understand. So we'll find that if I draw this trapezium. You know the property of trapezium that one pair of opposite sides are always parallel. One pair of opposite sides is always parallel. So we'll find in this case A, B, C, D. Okay. A, B, C, and D. Right. This is a trapezium. And here there is one more line is given. PQ. PQ is also given over here. Fine. Now you will find AB is parallel to PQ is parallel to DC given. AB parallel to PQ parallel to DC. Find PD is 12, AP is 15, that is important. AP is 15. Then PD is 12, PD is 12, QC is 14, QC is 14. Okay, AP is 15 here, then PD is 12 here, QC is 14, QC is 14, fine. And we have to find out BQ. What we have to find out? BQ. Okay, let's see. So this is a figure in front of you, and you have to find out BQ. Very correct. Now since we are studying BPT, in your mind you may think in this way. Okay, find AP upon PD is equal to BQ upon QC. Wrong. Whatever you said, that is correct. The thinking is correct, absolutely correct, but reason is wrong. BPT is applicable only to the triangles. In this case, A, B, C, D is a trapezium. Very important to understand. It's not triangle at all, therefore we cannot apply BPT. That is important. Okay, now you must be thinking then which theorem we have to apply. Even though application of theorem is also correct. AP upon PD is equal to BQ upon QC. Fine. Which theorem we are going to apply now? The theorem which is called as intercepts made by three parallel lines on two transversals. Very important. That AB, DC are already parallel, as well as PQ is also given parallel. So that is why AB, PQ and DC, all three of them become parallel. Then we are going to apply, so by theorem of the intercepts made by three parallel lines, on transversals. You will surely find names of the transversal AD and BC. AD and BC are two transversals. AD, PQ and DC are parallel lines. Okay, so therefore, by theorem on intercepts made by theorem on intercepts made by three parallel lines, AP upon PD, ratio of intercepts made by three parallel lines on one transversal is equal to intercepts made on other transversals. So you will find that AP upon PD is equal to BQ upon QC. Now simply substitute the values. AP 15 upon 12, 15 upon 12, that is equal to BQ upon QC. BQ I don't know. We have to find out value of BQ. While that of QC is 14. Right? Then 3 5s are 3 4s are. Transfer this 5 upon 4 into 14. that is equal to B. Positive number divisible by 2, 2 2s are 4, 2 7s are 7 5s are 35 upon 2, that is equal to B. 2 1s are 2, 17.5 is equal to B. What important thing you study over here? BPT is not applicable. That is very important because most of the times in class, whenever I ask the students, the first spontaneous response comes by BPT. No, that is wrong statement. That is what I like to make you very clear. This is a theorem based on intercepts made by 3 parallel lines on 2 transversal. Theory is said that is correct. AP upon PD is equal to BQ upon QC as that of BPT. But theorem is what? By theorem on intercepts made by 3 parallel lines. So this is how you find, dear students. We finished here. Question number 5. Please have a look. Okay, now let's do here question number 6. Question number 6 now. Easy questions, students. Not so lengthy, no groups at all. Only substituting the values and mentioning what type of theorem you are using. Are you using angle bisector? Are you using angle bisector or basic proportionality theorem or converse of basic proportionality theorem? That is important thing. Find QP. The next question is find QP using given information. Using given information. Okay, now let's I have to draw a figure over here. Triangle MNP is given. Triangle MNP is given. Triangle NNP is given. In addition to this, NQ is also given, and it is very important that NQ is given as angle bisector. NQ is given as angle bisector. Dimensions are given. MN is 25, MQ is 14, and NP is 40. Fine. And we have to find out Q. We have to find out QP. Very simple. Because you will notice by looking at the figure, if NQ is already given as a bisector, we can apply angle bisector theorem straight away. So you will find in triangle and NP. Answer. In triangle and NQ bisects angle MNP. NQ bisects angle MNP. This angle got bisected over here. Fine. Now angle N is the union of which two sides? MN as well as NP. So ratio of the sides of the angle. That is important. So by angle bisector theorem. MN upon NP. MN upon NP is equal to MN upon NP is equal to MQ upon PQ. MQ upon P. I apply over here angle bisector theorem, Mn upon Np, ratio of the sides of the angle. Okay. Corresponding parts in front of Mn, this side, Nq, in front of Np, Pq, fine. Mn is 25. So 25 upon Np, Np is 40. That is equal to Nq, 14 upon Q. Upon Q. 5 5 is 25. 5 8 we have to find out PQ. Okay. So if I transfer PQ to the left hand side, PQ is equal to 14 into 8 upon 5. Try to understand here. 5 5 is 25. 5 is 40. QP is equal to 8 upon 5. No problem as it is. Okay. So PQ is equal to 5 ones are 5. 5 ones are 5. 5 6 are 30. Correct. 16 fours are 64. 1 point is 22 units. Look here again. In triangle NQ is angle bisected. Angle N got bisected by NQ. Mn upon Np is equal to corresponding parts. In front of NQ, in front of Pn is PQ. See, same things. 25 upon 40. 5 5 is 5 here. 8 upon 5 after taking reciprocal, you surely find 5 ones are 5. Then 5 6 are 30. And then 16 fours are 64. 16 on the 16 plus 6, 22. So 22.4. That is PQ. Question number 7. Question number 7. Question number 7. In this case also you will find AB parallel to CD parallel to FE. Given AB parallel to CD is parallel to FE. This is what is given. Then find X. Then find X and A. Yes, it is very important. X as well as A. Both the things we have to find. Okay. Figure it is there. In the figure, you will find AB. Next to that is DC and F. DC and F. DC and F. So BA. Here there is point D. C. X, E and F. 8, 12, X4. Okay. Now find out X as well as A. Now you will find your students once again, but it is very clear in this case. It's not given trapezium or in complicated way, very simple way they have given AB is parallel to BC is parallel to FA. That means these three lines are parallel to each other. Why? This BF as well as AE are transversals. Straight away we can use theorem of the intercepts made by three parallel lines on two transversals. So, by theorem of intercepts made by three parallel lines on two intercepts on two transversals. Okay, now very simple. FD upon DB that is equal to FD upon DB is equal to EC upon CA. EC upon CA. Ratio of the intercepts made by three parallel lines on one transversal is equal to ratio of the intercepts made by three parallel lines on other transversal. So FD upon DB is equal to EC upon AC. Fine. Now FD is 4 upon 8. 4 upon 8 that is equal to x upon 12. X upon 12. 4 upon 8 is equal to x upon 12. 4 ones are 4, 4 twos are 8. Transfer this 12 on left hand side. 12 upon 2 that is equal to x. 2 6 are 12. So this is how you got x as 6. But question is not to find out only x. Question is also find out AE. So A dash C dash B. A dash C dash B. Therefore AE is equal to AC plus C. AC plus C. What is AC? AC is 12 plus 6. That is equal to 8. So this is how you get A. Already given these lines are parallel, so we don't have to think much. We simply have to say by theorem of intercepts made by three parallel lines on two transversal. FD upon FD DB is equal to EC upon AC. 4 upon 8 is equal to x upon 12. 4 2s are 8. Okay, then I transfer this 12 to 6 is 12, x is 6, 12 plus 6, 18. That's all. Very simple sum. Okay, dear students, I am going to end my lecture number 38 over here. Okay, I would like to stop here. In the next lecture, we'll continue this exercise only. Then I will teach you after. I think in the next lecture I'll be able to finish this exercise. Then later on, as you all know, the three tests of similarity. That test I'll explain you, and then next exercise is obviously depend on the test that I test. That's all. Thank you.